Peyton Manning's looked good in his debut so far, but it's only the first quarter, and oh, he just got sacked. So I take back everything I just said. We're going to be working on section 3.4, which is exactly what we've been doing lately, except that it's going to add an extra step. I would like you to pause this and try these review ones on your own. That was so funny. Good joke. Fantastic. So let's see how we did. 3x plus 6 plus 1 equals 6. I'm going to combine these right away, but you don't have to. I'm then going to subtract 7. I don't know why it keeps connecting like that. There we go. 3x equals -1. Divide by 3. So my answer is -1/3. On the bottom, I get 3x minus 2x minus 2 equals 4. Whoa, don't do that. Equals 4. I combine these to get 1x minus 2 equals 4. I add 2 to both sides. I don't know why my thing is so off right now. There we go. X equals 6. If you have questions, please bring those to class. Alrighty. New stuff. If we have x terms on both sides of the equation, one of the first steps that we should do is get all the x's to one side and all of the regular numbers to the other. So I am going to put all of my x's to the left and all my regular numbers to the right. So I have -2x, and I got to think what's the opposite of -2x, which is positive 2x. Okay, now I'm going to get rid of this, and I get 9x plus 19 equals 55. And all of a sudden, now we have the exact same stuff we've been doing the last couple days. I subtract 19, and I get 9x equals 55 would be 35 plus 1, or 36. Now I divide by 9, and I get x equals 4. Now to check my answers, I have to use the store function. So I go 4, store for x, and I have to do both sides of the equation. I get 7x plus 19 on the left side. I get 47, good number. And on the right side, I have to go -2 times 4 plus 55. And I'm hoping to get 47. I do. So now to prove my check, it's really easy. I just go 47 equals 47. And I'm done. Okay. Now down here, this is a similar problem, but the same concept. All of my regular numbers are already on the left. So I got to get this -9y over to the right, which means I have to add 9y. To both sides, of course. So those go away. And I get 80 equals 15y. Now I have to divide by 15. Now I think this is going to give us a fraction answer. So I'm going to put 80 over 15 over here. I'm going to divide by 5 right away. I know 15 divided by 5 is 3. 80 divided by 5 is a little bit trickier. So 50 would be 10. 30 would be 6. So this would be 16/3. Now to check, I have to do both sides of the equation again. So I'm going to first store for x. 16, not 19. 16 divided by 3. Store for x, and I go 80 minus 9x, it's 32, and then I go 6x on the other side, I get 32. Good. So I know I did it right. Alrighty, I would like you to try this one on your own. Okay, so we're back. No humming this time. Should get the radio on. I have Carly Lloyd stuck in my head. All right. I am going to put all of the x's on the left and all the regular numbers on the right. So the first thing I'm going to do is I'm going to add 10 to both sides. Okay, make sure when you add 10, you're not adding 10 here because that's an x and that's a non-x, apples and oranges. So I have 3x plus 4x equals 5x plus 3. Oh, I probably should have combined those right away, but that's okay. I can combine them now. I get 7x equals 5x plus 3. I now subtract 5x from both sides. I really like doing these problems just because at the very end of them, there's a sense of accomplishment. And I'm sure many of you disagree, but in the scale of math class, these are, I think, some of the more fun problems to do. They do take a while, though. 3 over 2. Now to check, we got to go all the way back up to the beginning and use the calculator. Now, I know a lot of you are not going to want to check, but man, it's frustrating if you get one of these problems wrong, you know, after you put so much work and effort into them. So taking the 30 seconds to check is totally, totally worth it. Because having to redo these from scratch is not fun. I get 0.5 on the left. On the right, I get 5x minus 7. Woo! Got it right. So 0.5 or 1/2 on both sides. I'm just going to write 0.5 because it's a check and decimals are best for checking. There we go. If you have questions, please bring them to class. I would like you to try these now. All right, let's see how these went. Up here on the top, I'm going to combine these x's right away. So I get 2x plus 4 equals 3x plus 8. Now I'm going to show you a trick here that you don't have to do by any stretch of the imagination, but it does speed you up. You can do multiple steps in one. So I'm going to subtract 4 from both sides to move that to that side. But I'm also going to subtract 3x from both sides. Okay? Does speed you up, but it does confuse some people too. So I get negative 1x here equals 4. If you did that in 2 steps, totally fine. So x equals negative 4. That does seem right. Yep. Down here on the bottom, I combine that to get 9x. I'm going to do the 2-step again, except I'm going to move the x's to the right side just to give it a change of pace. And I'm going to move that over to the left side. So I get negative 5 equals 3x. So I'm going to get x equals a fraction, negative 5 over 3. Negative 3. Yep, that seems right. Now, if you wrote 5 over negative 3, that is also correct. Okay, as long as you check your answer, you'll find that they do mean the same thing. Here's a what if. What if I give you an equation where something like this happens? I'm going to distribute on the left side, and I get 3x plus 6 equals 3x plus 6. Now, I should notice that these are the same thing, but just in case I don't, I'm going to continue on here and subtract the x's, and all of a sudden I get, oops, all the x's are gone. And so I get 6 equals 6. Now, some of you are going to remember, this is a true statement. Therefore, there are an infinite, I don't know why it keeps doing that, an infinite amount of solutions. Or, since these are both lines, these are the same line, meaning they intersect at every point, because they're the exact same thing. Now, if this was false, something like 0 equals 3, okay, that would mean that the lines are parallel or that they don't intersect, which means they have no solution. Okay, so everything's connected. We're doing linear equations, but we're also doing graphing and calculations and all that stuff at the same time. Okay? I would like you to try these on your own. They're all going to be special cases. So I want you to tell me if they're same line, parallel lines, infinite, or no solutions, or however you want to describe that. Ignore the end down here. Okay. I just found out that Peyton Manning can't turn his neck all the way to the left. That seems like it'd be really hard to play football like that. This one, I get 3x plus 6 equals 3x plus 4. I subtract 3x. Those go away, and I'm left with 6 equals 4. So this is no solution, or they are parallel lines. Whoops, if I could spell. Let's try that again. Down here on the bottom, we get 3x plus 6 equals 2x plus 4. I subtract the 2x. So I get 1x plus 6 equals 4. I subtract the 6, and I get x equals negative 2. And there you go. The code word for here is going to be steel. Steel. Okay. The assignment is here. Page 154, 21 through 34, 37 through 40. And there will be a quiz not tomorrow, but the following day. So I think by my schedule it would be Friday for those of you in algebra class. All right, we will see everyone tomorrow. Please bring your questions with you.